Hello and welcome everyone. This is Mohammad Izamam from SAIMEDHA ECET Coaching Center Koti, Hyderabad. SAIMEDHA Koti, Hyderabad is providing a golden opportunity to all the ECET 2024 and as well as ECET 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, SAIMEDHA Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. Ranks గురించి చెప్పాలంటే SAIMEDHA Koti, Hyderabad లో every single time, every single year we have proven that maximum ranks in all the branches ECE, EEE, mechanical, civil and computer science లో top 5 branches లో state first rank తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous ECET examination questions will be explained by expert faculties. My dear students, గుర్తుపెట్టుకోండి, ఓన్లీ ప్రీవియస్ ఇయర్ కాంపిటేటివ్ ఎగ్జామినేషన్ క్వశ్చన్స్ కొరకే సపరేట్ కోర్స్ ఉంటుంది, పే చేయాల్సి ఉంటుంది బయట మార్కెట్లో. కానీ SAIMEDHA Koti, Hyderabad లో ఫ్రీ ఆఫ్ కాస్ట్ we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous ECET examination questions with which you can understand the level of teaching, the expertise which is there in the SAIMEDHA Koti, Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the ECET 2024 and ECET 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video.
Hello everyone, this is Mohammad Inayatullah from the SAIMEDHA Coaching Center Koti, Hyderabad. So in this videos we are going to discuss all the previous ECET questions, okay, previous year questions of the topic simple stresses and strains, okay. So actually in this first chapter we have taken the topics as simple stresses and strains we have taken, and we have taken all the topics also, temperature stresses, what is the thermal stresses and strains we are having, as well as the complex stresses and strains. That questions also will be going to cover in this topic itself, okay. So simple stresses and strains. Let us start these questions what we are having. So first question is, if equal and opposite forces act on a bar subjected to elongate it, subjected to what? Elongate it, the stress developed is called. So what we are taking is, suppose we have taken a bar over here, okay, we have taken a bar or else a body we have taken. So on this bar, what we are applying over here, forces, equal and opposite forces we are applying on this, okay. Suppose one force it is applied on the left side over here, and similarly equal and opposite force. If you are applying equal and opposite force on the bar, which type of stress will be developed, okay. So we have to remember only one point over here. Suppose if the loads, whatever the loads or forces we are applying on the body, if it is trying to pull that body, if it is trying to pull that body, then it will be coming under tensile load. Which load we are calling over here? Tensile. Similarly, if you are taking the reverse of this part, suppose this body, this bar we have taken, and whenever we are applying the load, okay, it is looking like it is trying to push the body from the two sides. Whenever we are trying to push the body from the two sides, then it will be coming under compressive part. But whenever we are trying to pull the body from the two sides, then it will be coming under tensile. So if you are having tensile load, then which stresses will be induced? Which stresses will be developed over here? Tensile stresses. What we have to take? Tensile stresses. Similarly, if you are having compressive load, which stresses will be developed? Means compressive stresses. Okay, compressive stresses. So over here also let us discuss this part what we are having. So this part we have taken now. What we are having, if equal and opposite, this part we have taken, it is moving in left direction. This force whatever we are taking over here, it is moving in left direction, and this part it is moving in right direction. So two equal we have taken and opposite forces we have taken, then which type of stress is developed? Means directly we can go with the tensile stress, okay. So option 2 is correct. Now let us go with the next question. If a bar expands freely due to heating, it develops, okay. Now this question actually it will be coming under thermal stresses topic, thermal stresses and strains. Now what is the meaning of this thermal stresses and strains? Now listen here carefully. Suppose this body we have taken over here, Okay, this body we have taken. Now how we are getting the strain actually? Whenever we are applying the stress, whenever we are applying the load, due to that load stress will be developed. Depending upon that stress, what we are getting, strain will be generated. Okay, strain means what? Change in dimension by original dimension. Okay, so over here also what we are doing means, listen here carefully what we are doing. So as we know the stress strain diagram, stress versus strain diagram will be there. In that part we are having one Hooke's law. Hooke's law means up to proportionality limit, stress will be directly proportional to strain. Means whenever stress is increasing, strain is also what? Increases. We are having directly proportional concept over there, and that is coming under what? Hooke's law. But in this, it is not compulsory that whenever the stress is increasing, there should be strain increases over here. Okay, increment should be there. It is not like that. We are not having that condition. Whenever we are considering Hooke's law, that is the condition we are having, stress is directly proportional to strain. But if you are going out of this content, means some other content we are taking over here, as we are discussing what thermal stresses or strain. Now in this part we are not applying any load. Okay, we are not applying any load over here. If you are not applying any load, we are not having any type of stress. Okay, so what we are doing, we are heating this bar. Okay, due to heating, it is given clearly in the question that due to heating, means whenever we are heating this bar or body, whatever we have taken, now due to that heating, due to the temperature changes, whenever the temperature is changing, due to the changing temperature, what is happening, we are having the strain in the body. What is the meaning of strain now? Strain means a change in dimension by original dimension. Okay, leave that part. Either it is extending or else it is contracting, leave that part, that is secondary. But what is the primary point over here? Primary is whenever due to heating, whenever we are heating that bar or body, due to that heat, the body is having strain values over there. Strain means we are having some changes in the dimensions. Okay, so we are not considering any Hooke's law over here. Apart from the Hooke's law, whenever we are taking this concept will be coming under what? Thermal stresses. Okay, so as we are having strain over here, what we are having, as we are having strain, but we are not having any stress. We are not having any stress. So that's why the topic will be coming under what? Thermal stresses or thermal strains. So let us see the options what we are having over here. So it develops thermal stress, it develops tensile stresses, compressive stresses, no stresses. Okay, so just now what we have discussed, whenever we are heating this part, what we are getting only strain, we are getting strain, but we are not getting stress value over here. We are not getting any stress means, then what we can write over here, it develops no stress. Okay, now some more some other type of question what we are having means, let us see this part over here, listen carefully. Now one side we have taken some cantilever beam over here. If you are taking cantilever beam, now listen carefully. So it is fixed at one end. What we are having, it is fixed at one end. We have taken some rod. Let us take it as a rod. After taking this metal rod, what we are doing means, as it is fixed at one end and it is free from other end. Free from what? Other end. So whenever we are heating this, what is happening means, this bar or rod, whatever it is having, it is trying to change its dimension. It is trying to what? Changes its dimension. Whenever it is having changes in the dimensions, we can say that part as strain we are having some value. Strain is not equal to 0. Strain is not equal to 0, but stress is what? Equal to 0. In this content we have taken. Now what is happening means, suppose if you are taking a rod we have taken, but that rod it is fixed at both the ends. Now what example we have taken? We have taken the bar and it is fixed at both the ends. Now whenever we are heating this rod or bar, now what is happening means, it is trying to change its dimensions. It is trying to change its dimensions, but as it is fixed at this end, what is happening? It is not, in practical, it is not able to do the changes over there. Okay, so it is trying to change the dimensions, but due to this fixed end, it is not happening practically. So if it is not happening practically, so what is resisting over there? What is resisting? Due to compressive part, means this part, it is applying some compressive stress over here. Due to that compressive stress, now the stress is generating. Now the stress is generating because it is restricting over there. As it is restricting, so stress will be generated, stress will be developed, and which stress is developed means a compressive stress, because if it is trying to elongate, with the help of this fixed end, it is trying to contract. Whenever it is trying to contract that rod, we are calling it as what? Compressive. Okay, we are calling it as what? Compressive stress. Okay, So already this topic you have learned, you have seen in the video lectures also. So only overview what we are having means whenever we are having the free end, so it can elongate. So we are having strain is not equal to 0, we are having some strain value, but stress will be 0. But as we are having fixed end over there, as we are having fixed end, so we will be getting which stress over here? Compressive stress will be developed. But according to this question, as we are as it is not mentioned any fixed end or free end over here, directly what is given means if a bar expands freely, if the bar is expanding freely, then we are not having any stresses, we will be having only strain. So we can go with the fourth option, which is no stresses. Now next part, the stress developed in a body due to suddenly applied load when compared to applied gradually. Okay. Now this topic we are taking it as a strain energy. Strain energy topic also we have taken in this first chapter only. Now strain energy what we are taking means, let us see this part, maximum stress induced in a body, maximum stress induced. Listen carefully now. So first case we are taking it as sigma is equals to P by A. First case we have taken it as sigma, maximum stress induced, the sigma is equals to P by A. This is for gradually. This is for what? Gradually applied load. Okay, gradually applied load. Now similarly, if you are taking sigma is equals to 2 into P by A, okay, these are the final results we are having, 2 into P by A, then we can take this part as a suddenly applied load. What we are having? Suddenly applied load. Okay. Now one more formula we are having it as sigma is equals to P by A, we have taken P by A of 1 plus under root 1 plus 2A EH divided by PL. Okay. And this formula, it is for impact load. Okay, this formula it is for what? Impact load. So in this what we are taking over here, gradually means what is the formula we are having? P by A. Suddenly means what is the formula we are having? 2 into P by A, means twice, two times of gradually applied load. Now similarly if you are having impact load, then we are having this formula P by A of 1 plus under root 1 plus 2A EH by PL. Okay. Now we are having similarity between suddenly applied load and impact load. Now what is that condition we are having means, listen carefully. If H is equals to 0, if H is equals to 0, we are taking this part, H is equals to 0. Now what is happening over here? 0 into this complete part means 0, 0 divided by PL means what is 0, 0 plus 1, 1 we are getting, root 1 is equals to 1, 1 plus 1 is equals to 2, 2 into P by A. So for this impact load formula what we are having, if you are taking H value is equal to 0, then it is becoming what? Suddenly applied load. Okay. So in this question what we are having, the stress developed in a body due to suddenly applied load when compared to gradually applied load means what we are having? Twice, means 2 times. 2 times we are taking over here means let us go with the second option. Second option, 2 times is given over here. So let us go with the 2 times of the gradually applied load. Okay. So this was the option. Now next question, breaking stress is. Now what is the meaning of breaking stress actually? Breaking point, failure point, rupture point, we are having this part now. So let us try to discuss over here by using the diagram what we are having. Stress strain diagram will be there. By using the diagram, let us understand this part. So breaking stress is less than ultimate stress, greater than ultimate stress, equal to ultimate stress, less than working stress. Okay. So we have taken this diagram we are having. So on the y axis we are taking this part as a stress. Stress means we are taking it as load over here. Okay. And this part we are taking it as a strain. Strain means we are taking this part as extension. Okay. We have taken this part as what? Extension. Now let us draw the diagram what we are having over here. Suppose this diagram we are taking. This is a straight line we have taken. Okay, this is the diagram we have taken over here. So for stress and strain, we are having this diagram. This diagram we have taken. Now let us mark the points what we are having over here. What are the points we are having? Suppose this is a point we have taken. This is one point, then this is one point we have taken. So this is 1 point we have taken, this is 1 point, this is 1 point, this is 1 point, then again this 1 point, and this is last point. Okay, like this we have taken. So this is A, B, C, D, E, F. Okay, so all these points we have taken over here. Now what is the meaning of this point? So first point we are taking it as, listen here carefully, A point. If you have taken A means we are calling up to this from O to A, O to A, it is looking like a straight line. So whenever we are having straight line, what is the meaning of that part? Straight line we are getting means stress is directly proportional to strain. So whenever stress is directly proportional to strain, whenever the stress value is increasing, strain is also increasing up to proportional limit. Up to which limit? Up to proportional limit, we are calling that law as a Hooke's law. Okay, so A, up to A we are calling this part as a proportional limit. Let us write over here, proportional limit. Okay, this part we have taken. Now what is B we are having? B means we are taking it as elastic limit. B we are taking it as elastic limit. Okay, now what is elastic limit we are having? So up to this point, whatever B point we have taken, up to that point, if you are applying the load, what will happen? Stress will be developed. Due to stress, strain will be developed over there. But after removing the load, if the body, it is regaining its original shape and size. Okay, if it is having the capability to regain its original shape and size after removal of the load, then that property we are calling it as what? Elasticity. Okay, what we are calling? Elasticity. So this is the last limit we are having over here. Point B, we are calling it as elastic limit. Inside this limit, okay, in this region only, up to point B, from O to B, whatever the region we are having, in this region, if the body is loaded, so if you are removing the load and it is having the capability to regain its original shape and size, then we are calling it as what? Elasticity. Okay, means we are calling this region as elastic region. What we are calling? Elastic region. Now whenever it is crossing this point B, after it is crossing its point B, this complete region will be coming under what? Plastic. It will be coming under what? Plastic region. Means what is the meaning of plasticity now? The property plasticity we are having. Plasticity means now after removing of the load also, the body, it is not having the capability to regain its original shape and size. If it is not having the capability to regain its shape and size after removing the load also, then we are calling that part as what? Plasticity, means permanent deformation. It will be permanently deformed. So point B we have taken. Now what is point C we are having? Point C. Point C we are taking it as upper yield point. Okay, upper yield point or upper yield limit. Now next D. D we are taking it as lower yield point. Lower yield point. Okay, this part we have taken. Now after this elastic limit, whenever we are going on increasing this part, so beyond this point B, what we are getting? Yield points we are getting. We are calling this part as upper yield point and lower yield point. Okay, so this part we have taken. We'll be having more increase in the strain part over here. If you are decreasing the stress also, what we are getting? We are getting the more strain over there. Now next we are taking it as E. Point E we have taken. Point E we are taking it as ultimate point or ultimate stress. Okay, ultimate point. At that ultimate point, what we are having? Ultimate stress. Now F we are calling it as a breaking point or failure point. Okay, like this we have taken. Now let us see the question what we are having over here. Breaking stress is, this is a stress value we are having. These are the stress values. So we are starting from 0, so it is going on increasing over here. Okay, now let us see simple point over here. So this what we are having? Ultimate stress. This is the ultimate stress we have taken. So we are having ultimate stress value over here. Okay, suppose this is the ultimate stress value we are having, and what is this value we are having? Breaking stress. So if you are taking this breaking stress value over here, this is breaking stress value we are taking. So what we can say over here? Breaking stress value, it is more than ultimate stress or less than ultimate stress. So directly we can see this part over here. This is ultimate stress and this is breaking stress. So breaking stress, it is less than ultimate stress we are having over here. So we can go with the first option. Breaking stress is less than ultimate stress. Okay, so we are having the first option as correct. Now let us see the next question. Hoop stress is a dash stress, means which type of stress? This question is also most important and it is repeated over here. So what are the options we are having? Bending, compressive, tensile or shear. Okay, let us take one example over here. What we are taking the example means, suppose if we are taking one cylinder over here, suppose this cylinder we have taken, if we have taken some cylinder and in this cylinder we are trying to fill the gas. Okay, we are trying to fill the gas over here, pressurized gas. If you are trying to fill the gas in this part, now what will happen whenever it is filling over here, whenever the gas it is moving inside, so what will happen means it is trying to occupy all the space what is happening over here. It is trying to occupy all the space what it is having. So whenever it is trying to occupy all the space and it is going to attach the walls what we are having, the outer surface what we are having, so it is going to attach with that part, and whenever it is the gas is filling up, it is completely filling up this space. So if you are seeing this arrows over here, if you are seeing this arrows, what is the meaning of this part we are having? Means whenever it is getting filled, it is trying to elongate. It is trying to what? Elongate over here. Elongation. When we are getting elongation means increase in length, increase in dimension. When we are getting that increase in dimension means if we are using the tensile load. Whenever the tensile load is applied, we will be having the increment. Understood? We will be having some increase in dimensions. But whenever we are applying the compressive load, what we are getting? We will be getting shortening, means decrease in the dimensions we are getting over here. Okay. So over here also whenever we are filling this pressurized gas over here, the gas is occupying, means it is filling that space, whatever the space we are having, and it is trying to elongate that part. If it is trying to elongate means a tensile load is applied. If the tensile load is applied means which stress? Tensile stress. Okay, so this part we have taken over here. So this is coming under what? This stress we are calling it as what? Hoop stress. We are calling this part as what? Hoop stress, and we are having one formula over here, sigma h. Hoop stress it is equals to PD by 2T. Okay, by using the formula also, if you want to find out any value over here, we can find out with the help of this formula, PD by 2T. Okay, now which option will be correct over here for this question? Means hoop stress is a dash stress, bending, compressive, tensile, shear. Means let us go with the tensile over here, tensile stress. Okay, so option 3 is correct. Now next question, the Poisson's values for cast iron varies from. Now this is also most important. Number of times the Poisson's value has been asked in the examination. Okay, now let us see. Let us discuss what are the complete values we are having. So first let us take for concrete. For concrete, let us take it as the Poisson value we are having it as 0.2. Okay, what we are having? 0.2. Now next let us take it as a cast iron. If you are taking cast iron means it is like a 0.23, approximately we are having it as 0.23. Okay, this part we have taken. Now next we are taking it as a steel. If you are taking steel over here, if you are taking steel, now this is like a 0.25 to 0.33. Okay, like this we have taken 0.33. Now if you are going for copper, now the value it is like a 0.26. 0.26 we have taken. Now if you are taking brass over here, if you are taking brass, it is like 0.3, 0.26, 0.3 we are having. Now if you are taking aluminium, if you have taken aluminium, it is like a 0.32. Okay, 0.32. Similarly, if you are taking rubber, then it is like 0.5. Okay, for rubber we are having the value as 0.5. 0.5. Now next cork will be there. Okay, cork we can't take any value, it is like a 0. Okay, cork like this value we have taken. Now let us see the question what we are having over here. Now the Poisson's value for cast iron what we are having. Cast iron means what we have taken over here. Cast iron means 0.23. Where we are having 0.23. 0.23 means 0.23 to 0.27. 0.23 to 0.27 means first option. First option is correct. Okay, first option. Now next, a stressed string possesses the energy is the form of internal energy, strain energy, potential energy or kinetic energy. Okay, now in this what we are having over here. So what will happen whenever the body is strained? Whenever the body is strained means what is happening over here? Suppose this is a body we are having, and if you are applying some load over here, whatever the load may be, what will happen? There will be strain in the body. So whenever we are having the straining effect in the body, whenever the body is strained, what will happen means the energy will be stored. What will happen? The energy will be stored due to that straining effect. Okay, so this part we are taking over here. So in this part also we are calling in this part as, let us see this one, whenever the body is strained, whenever the body is strained, energy is absorbed, energy is absorbed in the body due to what? Due to straining effect, due to straining effect. So this energy which is absorbed over here, this energy we are calling it as a strain energy. What we are calling? We are calling it as a strain energy. Okay, so which option will be correct now? Internal energy, strain energy, potential energy, or kinetic energy means let us go with second option, strain energy. Okay.
So my dear students, for ECET 2024 and ECET 2025, SAIMEDHA KOTI Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi SAIMEDHA KOTI Hyderabad in this very week, guys. In this very week only we are providing the maximum concessions. Aa concessions evaithe unnayo, concessions ఏ విధంగా ఉంటది, batches ఏ విధంగా ఉంటాయి, with materials, without material, online coaching, total మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్ లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద SAIMEDHA KOTI Hyderabad as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous ECET examination questions. I wish you all the best. This is Mohammad Inzamam signing off.